Right. Welcome everyone. Hope you're having a good evening today or tonight. Yeah. So let's begin. So this is the name of the talk. Not sure if you're familiar with the idea of putting the genie in the bottle. You know, the genie bottle is the smartphone. So this is about it's like a crash course on running LLMs on mobile, on Android specifically. So this is me. And let's start. So you may be wondering, right, why would you want to do that, right? Because most people would probably think that these things are very hardware intensive, right? So how would you even run something like that on your mobile? And you already have ChatGPT or Gemini on the cloud, right? So why bother with this? So first of all, I'm going to try to justify why would you go this direction. So this is what you need to understand what gets buried in the news, right? So SOTA, these state-of-the-art models, they get the most attention, right? These are the things that are being released every week and breaking benchmarks and stuff like that. So these is like the model's iceberg. So these are the thing on the top, right? So you have Claude, you have O1, or Grok, or Gemini, DeepSeek. And the thing is so fast that I made this slide yesterday and it's actually outdated because Google released Gemini 2.5 yesterday. DeepSeek is R3 or V3, I don't know. Anyway, it's super fast. They're getting bigger and bigger and they're the ones that get the most attention. But what I'm arguing is that there are a lot of other models coming out which don't get as much attention by the general public, even by developers, which are these smaller models. So, for example, I was in Paris 2 weeks ago. Like Google was releasing the Gemma 3 model, for example. They have a bunch of versions, a bunch of sizes. Mistral, the week after release, this Mistral Small 3.1, which is also super capable. Llama is the one from Meta. So these are smaller models which are much better and much more capable than they used to be. And just to give you a perspective on what do I mean by better, the Gemma 3 27 billion, the biggest one of these 27 billion parameters model. This is on par with ChatGPT 3.5, which is like 6 months ago. So it's like, this is going super fast. And I think humans in general are not very good with exponentials, right? It's very hard to understand when things are going super fast. It's really hard to gauge, to gauge. I don't know how to pronounce that word. The speed, right? How fast is it going? How big is it going? With all the hype, with all the talk, you know, everyone's heard about like that crypto was going to change the world, and I think everyone's kind of bit by that. I don't know. So what I call these guys are they are like top left corner models. I don't know if this is actual something that people say, but I'm going to justify. So this is like another category of breakthroughs happening. I'm justifying that. There's another category of breakthroughs happening in parallel. These are very highly efficient and capable open source model. This is another thing. They're open source. Most of these smaller ones, super fast, they're open source, which is interesting. I mean, if you want to outsource the world's knowledge to a software, might as well be open source, right? So these models are hitting benchmarks. Yeah, I just said with the slide. So SOT was like 6 months ago, right? So why top left corner? Generally, it means like on the vertical axis, you have like the performance, and on the horizontal axis, you have like the resource it takes. So in this case, it's about time. So this is latency. So this is the Mistral one in comparison with GPT-4o1 mini. So you see it's much harder, much bigger performance, even from Gemma. Yeah, because this was released just after Gemma, right? And yeah, so this is one example of like, it's the top left corner, right? So it's in that region of the graph. And the Gemma, when it was released, was the same thing. It was like on the very high performance, on the vertical axis. In this case, there's like ELO score, which is how one of the ways they're measuring these models. And on the horizontal axis is like the billions of parameters, the size of the model. So you see, like, it's not as good as the other ones, but it's still up there, and it's very much less resource intensity, right? So this is like just one of these rankings they have for AI. So Gemma is right there. If you actually look at the score, it's very close to super big models, right? And this is about performance. So this is Gemma 27B model. For example, it takes only, this is about the numbers of GPUs required to run it. So you can see, like, it's competing in a very, it's very resource efficient. Okay, enough of that. So next thing, why would you want to run it locally, right? So my slide here is not working well. So why would you want to do that, right? So there's basically these 4 main reasons. So cost, you're paying for, when you're running a large language model, you're paying by the token, right? So more tokens, more cost, and basically every time a user will run something, it's going to cost more. So if you have this on the edge, on the device, it's free, right? You don't have to pay for the tokens. You're paying with the user's hardware, basically. So with the CPU that's actually running the thing, not a server on the cloud or charging by the token. There is also privacy. If that's something, for example, if you're processing important data, something that you don't want to be disclosed with anyone else. This is also very, like, it would be a good reason for you to run a model locally that doesn't send data anywhere. The other reason would be latency, right? You don't have to do round trips on the network, so that would also be a good reason. If the model is good enough, that would be a good reason. I mean, you could use the model on a plane. These things, I think in a very short time, okay, planes, you can get internet. Maybe there's an argument for having connectivity most places in the near future, but in any case, you don't want, I think in the near future, we're going to be very reliant on these things. So being able to access a model without internet can also be an argument, if you think about that. Yeah, that's offline availability. Right, so these are some of the reasons. Right now, okay, so these are the reasons, right? So then we can talk about how can you run this on a device, right? So what are the options? How can you do that? So right now you have basically 2 options for running on device, specifically Gen AI. So I'm just gonna go briefly over them, and then I'm going to go in depth. So there's this option, the first one. Yeah, small parenthesis. When I created this talk, I was just going to talk about this one. The talk, like AI Edges SDK, this is the thing, but I'm going to give you a bonus with another one. That's why I was still writing slides 10 minutes ago. So the first one, system-wide LLM model, right? So these are built directly into the platform. So this way you can run Gemini Nano using this AI SDK thing, right? So this AI Edge SDK is the easiest approach. The model is going to be shared by all apps. So all apps, it's just think about it as like a system resource. Like there's this model in the device, and any app can use it, can have access to it. So it has support for LoRa adapters. So this is a way to efficiently fine-tune a model. I'm not going to go in depth on those things, but just thinking that you can fine tune it, like with I think this is the bottom line. With a very small file, you can customize the model. So each app can customize the model for its need. What else? The model updates are managed by the platform, because this is a big hassle, right? So if you want to have the speed these things are going, there's a new model every day, so you want to keep updating it, and With this solution, that's handled by the platform, so by the OS, so you don't have to care about that. You just have to implement it properly, and the updates will just happen for free. It also has built-in safety features, so there's there's the concept of jailbreaking models. So there's people that try to make the model do things that wasn't supposed to. So imagine if you were in a big organization or a big company, you don't want, it's bad PR if your model is saying shit on the internet and people are posting about it. So you would have to solve this problem by yourself if you were doing it yourself. But with this solution, it's already done by the platform as well. So built-in safety features. And then this is a drawback, right? So this is available only on high-end selected devices. So we're talking Pixel 9, Pixel 8, Samsung 25, I don't know, S25, like the top of the lines. So there's a few devices that support this because, and then this is the thing. Right now, for example, the Gemini Nano model is 3.5 billion parameters, which generally speaking takes a lot of size and also takes a lot of RAM to run. Memory basically, yeah, because I think it's shared. It's a SoC, right? So it's shared, the memory on the device and GPU and blah, blah, blah. So in the end, bottom line is it takes a lot of memory. Reason why the latest Pixel 9 from Google, all the models, all the Pixel 9 models have extra 3 gigabytes of memory. I think they went all to 16 gigabytes. So that's one of the main reasons. It's not they're giving memory for free, it's that just they're preparing these devices to be able to support these kind of things. Right, that's one solution. The next solution is the self-managed models, right? So in this case, your app must handle everything. So you need to handle the model downloads, the updates, the setup, initialization, resource management. For example, if you run, it's going to start taking a lot of memory. You want to be mindful of that, so you kind of have to manage everything. But you can run mostly, like basically any text-to-text LLM on the device. This is not 100% true. That's why the asterisk, but it's almost there. You have full control, so you can bring your own fine-tuned model, any model that you can download, and basically runs on any device. So as long as the device can take the hardware hit, there's no limitation. Like the other ones, just block. You're not gonna get Gemini Nano on a Samsung S20, but you can run actually any model on a Samsung S20 with this solution, right? So this solution is actually called MediaPipe LLM Inference API. That's the full name. The actual thing is, I think back in the day, Google created this MediaPipe suite of solutions. So there's, I don't know, 6, 10 SDK, I don't know how many, there's a lot. So for vision, I don't know, everything ML, machine learning related. And they just created I think it's probably more than a year, the LLM Inference API, which, as you might have guessed, it runs LLMs. So for now, it's only text-to-text, and you can switch models with it, like you can load multiple models on the device and you can switch between them, and also you can support LoRa adapters, but it's also more involved because it requires you to know a little bit of what you're doing. It's not just something that like an API that you call a method on, so that's the drawback. But let's go on like deeper now. So what's actually the AI Edge SDK, right? As I said, you can interact with Gemini Nano locally, and it's the easiest way to run on-device LLM on Android. Requirements. First requirement, compatible device. Don't have a compatible device, it's not going to work. Second requirement, and this starts getting interesting, like you need a valid beta version of the AI Core APK. So it's a specific app you need to have on your device. And you need also another APK called Private Compute Services. These are There are a few APKs like that on Android. I think you might have noticed like there's like system APKs. So this is a bit like that. So these are them on the store. You can actually find them on the store. You're not going to be able to install it on devices that are not supported, but you can find them on the store. So they look like this. And yeah, so Android AI Core, private compute services. And this is how you use it on your app. So basically, the AI Edge SDK, the Cradle dependency, it's called AI Core. Yes. But this is how you add it to your app. And this is how you run it. If you used Firebase, Vertex AI, whatever, the SDK for Android, it kind of looks like that too. If you use the generative AI SDK library, it kind of looks like that too. It's very, very similar. I think it's exactly the same. You know, you pass in a configuration, how many tokens the output is going to be, like the limit, temperature, you know, like these weird parameters. You can look up the docs. I think in any LLM, you kind of have these similar parameters, right? So this is not different. And then you can generate the contents like synchronously or asynchronously, right? So this how you do it synchronously, I think. Right, so this is the actual architectural diagram, whatever, for the AI Edge SDK. So you can see on the blue box, you have your Android app, you have the AI Edge SDK, and this blue box is going to talk to this thing which is inside the OS, the Android OS, which is called AI Core. So this is that APK. And this APK, this AI Core thing, it handles the LoRa adapters. It actually hosts the Gemini Nano model and the inference engine around it and the safety features. And that thing will talk to the TPU or NPU accelerator, which is the hardware part, like the optimization under the hood. So kind of looks like that. And let's talk about, just because we just saw, right, there's the AI Core. We talked about AI Edge SDK. Let's just look at the AI Core part. So this is the OS level integration. It handles the model deployment and the hardware abstraction layer. The next thing is the PCS and PCC. So this is a bit complicated, how it works. But in the end, you just need to understand that when we say that this is a secure thing and it runs only on device, they kind of have to prove it, because they can't just say it's going to be, but they need to create the architecture around it to enforce it. So this is how Google does it. And just understand it as a sandbox that it's on the OS level and restricts the availability of the information that the models get from the apps. So basically, the data from the user doesn't leak anywhere, and it's running the sandbox. And if you really want to get a sense of what does that mean in practice, if you have a Pixel device, you might have noticed they have like this now playing feature, or live caption, or smart reply. Just think about it for a second, like the smart reply one, for example, that I think it works on WhatsApp. So depending on the conversation you're having, it's going to suggest a reply. So it naturally needs to see the conversation, right? But with this system, it doesn't really directly see the conversation. You know, like it's like a delegate or something. There's a full paper explaining how this actually works. For example, the now playing feature is, if you think about it for a second, it's super creepy, right? Your device is listening to all the music all the time, all the sounds, and how is that safe? You know, this is how it works, and it's not that creepy because of this whole architecture. And this architecture is the thing responsible for having access to the models and downloading stuff. So it still can download stuff and update the models and even train the models without having access directly to the data. if that makes sense. So this is the full architecture when you put it together. So you have the app, the API surface, the AI SDK. So it's going to talk to the AI core thing and gets the input. There's a filter for safety. There, on the input, there's a filter for safety on the output. There's feature flags there. It handles downloading the weights through the service, and everything works, right? You really don't need to understand exactly how that works, but just FYI. So a little bit of a hands-on now. How are we doing with time? Yeah, I think it's okay. Yeah. So if you run it first time, you're going to get something like that. So basically not available. So the model is not there. So then you have to download the model. So these are kind of what it looks. There's a demo app. So I'm just showing the logs from the demo app. And you can see there's basically, I'm going to show you how it looks, but there's basically a download listener thing. So you can see the model downloading, and when it's completed, you can see also the size, right? 4.3. Let's see, what does that look like? So I use this app called Glasswire that monitors the network, and you can see exactly which app is downloading what, and there you go. Private compute services, 3.909 gigabytes, right? So this app that we just heard, it was supposed to download the model, it was actually downloading the model. Who would have thought? And it lands on the AI core. And when you inspect the AI core APK, you can see that it's taking 4.338 gigabytes when it's uncompressed. So basically, I think it's downloading like a compressed version, then it's uncompressed on the app. So it does take a lot of space on the device. So this is also how we handle these download updates. So this is what it looks like in the code. Basically, you have this class with download callback, and you get information of the progress. You pass that in to the generative model, the configuration, and yeah, then you need to run this, which is like checking if the model is actually working, is it actually on, right? So it checks if the device is compatible or not, check if the model is downloaded. If it's not downloaded, it's going to trigger the download, and you have to work around that to make it work. And yeah, so you have just to call this method, right? Prepare inference engine. What's next? Right, so this is context streaming, like a very poor man's implementation, but it's a very simple one, but that's what it looks like. This is like, you launch a coroutine and you pass in a prompt, so that input, so basically, like a string, and then you build a prompt, and then you can collect the response by chunks, just like when you're interacting with ChatGPT, there's text coming out. So basically that, so you're just going to append it to this result. And since it's a coroutine, you can cancel it midway if you want to, like the user leaves the screen, so you can just press cancel. Yeah, so basically that's basically it, Gemini Nano in a nutshell. That's how you interact with it. There's these frameworks, stuff, blah, blah, download the model, run it. Not that complicated. And this kind of what it looks in action. Can I play from here? No, of course not. Right. Yeah, this is the kind of speed you can expect from it. So this is a 3.5 billion parameter model. I think it's from last year. So it's super old, very, very old for AI standards. And it's not that smart. I mean, this answer is not too bad, but it's not that smart. We're going to talk a little bit more about that after this. So this is the other solution, right? So we went over the fully managed one, and this is the very custom one, so media pipe. So this is the LLM inference API. You can run LLMs on the device, and there are a bunch of model formats, right? There's a bunch of model formats, and these are like, just think about like file formats, and these are the ones it supports. So it supports PyTorch, which apparently is already covering a lot. Like, for example, if you download something from Hugging Face, I think it's usually they're compatible with PyTorch. But in any case, the media pipe is something from Google, and of course it is going to use TensorFlow to run. And there's a method, so there's a way for you to convert a model to Google's format, which is LiteRT, which was formerly known as TensorFlow Lite. So the LiteRT is like light runtime, something like that. So okay, this is the format, and this is what it supports. This MediaPipe LLM Inference API. It has for Android and iOS and web, because now there's LLMs on the browser as well, and this is how you run it. So first thing you need to do is getting the model on the device. So here, like size matters. Bigger models are better, but they also take a lot of space. You have to do the trade-offs there. And on prod, this is not what you're gonna do, but if you want to test it, right, you can just ADB, just push the file directly into the device, and you see how it works later on. So you can, like just remove what was there, create a folder again, push it into the device. And this is the setup. First, there's the LLM options, so you need to pass in the path to the base model. So that path you just define there, you're probably going to use that again. Set a bunch of parameters. If you want the LoRa adapter, you also put the path there. And then you create the options thing. Then you take those options, and I think I messed up. This is very similar to the previous one. You create a session with the options. Is it? LLM create from options. Oh God, I duplicated. Sorry about that. Anyway, you set it up. You have to create a session. You have to create the options, and you have to create a session, because not all requests to the model are going to be in the same session. You just think about like when you create a new chat on ChatGPT, for example, you're creating a session. And the session has basically all the context of the conversation. So on each turn, each time you talk to the LLM, it's going to take the whole context back, right? And the longer you talk, the more text there is there, the more memory is going to take. So on the device, you want to be very mindful of this session thing. So you want to clear the session, because essentially it's going to crash your app if it gets too big. And this is how you generate a response. You have a listenable future. Yes. So you use that to get the the updates similar to what we saw before. What I'm doing there. Yeah, you get a partial result, and you get this done flag. So you can basically know when it's done. You can just update the UI. So it's a very small example of how it works. Yeah, so a few gotchas. So you need to pick a model, right? So this is already hard because there are so many models. Then you need fine-tuning, like with LoRa adapters and whatever, and also downloading, updating the model. And why they need to be fine-tuned? Because most of these models, like especially the smaller ones, they're very dumb, right? They're not super smart, and they're not like very general purpose. They kind of look like it's general purpose, but as soon as you start poking around, you see, oh, okay, this is not that smart. But the good thing is it's getting very easy to fine-tune a model with LoRa adapters. And these days you can actually, you can, even the data part, which is the hard thing, you can use a LLM to generate data to train another LLM, so it's getting easier. So an example of that, of this kind of stuff, not particularly related to LLM Inference API, but for example, the Pixel 9, whatever or I don't know if no, I think it's just a new one. They have this weather app, and on this weather app, they have this AI summary. So basically, it looks at the screen, takes all the data from the screen, and creates a text, like a summary, like a weather report. And that is the Gemini Nano model with a LoRa adapter trained for creating this summary, so it's good at creating weather summaries. There's also the voice recorder app, that generates transcripts. So you can press a button, it creates a summary of the transcript. It's also, I think it's also fine-tuned for that. So, right, so these are the current limitations. Limited device support for in the case of AI SDK, right? The model size quality constraints if you're running the LLM inference API and smaller models. Because when you're running these smaller models, you probably, if you're not, it's kind of a given that you're not targeting only high-end devices, right? So you want more availability. So more availability means you need a smaller model. So the constraints are bigger, right? So the hardware requirements, something like space, for example, like, I don't know, like imagine if you're in an environment where data is super expensive. We were just having this conversation there at the conference there. People were like saying like this is like unfeasible for something like in some regions of Africa, like that you pay by the megabyte of, you know, so space is a problem. People are just not gonna want to use something like that takes a lot of space, and you're paying for something that, you know, you kind of have to pay for an app just because of that. So these are the constraints, right? So there's also the narrow use cases. So basically, these are the officially recommended use cases right now. Text rephrasing, smart reply, proofreading, summarization. So kind of, you know, not quite there yet. The small context window, as I said, the bigger the context window, the more memory is going to take. So it's also a big problem. So you probably might be thinking, why should you care about this at all? Like, if it's not there yet, like, why? I can really see these small models beating cloud proprietary ones, right? But I kind of have this hunch. Do you remember mainframes? Probably not, I don't know, like some people do. But have you read about it, right? I haven't touched a mainframe. But there was a point there was mainframes, and you know what terminals used to mean? Terminals was just a keyboard with a screen, because computers were not good enough to be their own thing. You know, you were just talking to the mainframe, right? So, so this is an example of a 70s, you know, like from 70s to 80s. These are the mainframe era, right? And this is from Wikipedia. 2 9-track tape drives, 2 disk drivers, high speed. I don't know what even those words mean, but you need a room for that, right? And these are run by the terminal. So this box there, it's not actually doing anything. It's just talking to just communicating. And right, the mainframes were seen as serious stuff, and these microcomputer things, these were like, you know, toys at some point. So I heard. So I think there's a path here for, generally, this is my hunch, right? I'm not saying it's going to be its own thing, but it's definitely going to have a place, especially when it starts getting really good. So for example, the 27B parameter Gemma model is already super capable. And I mean, it runs in my machine. I can run like 32 billion parameters models already on my machine. And this is like better than ChatGPT last year. You know, if you extrapolate a little bit, you can see the direction this is going with all the hardware improvements as well on the device. I got access the other day to a NVIDIA Nano thing, like it's like basically a Raspberry Pi that can run a Gemini or yeah, it can run Gemma. So things are getting super smaller, faster, you know, performance is getting better, the models are getting better. If you put all things together, I think there's a place in the near future that these things can actually be useful for something. And I'm not talking about, and this is important, like we're not talking about just chat application, because I think people are locked in this, like, oh, I'm going to chat with this thing, like, well, why would I want to have a chat in my company's app? But it's not about that. Like if you extrapolate a little bit, with MCP, I'm not sure if everyone knows what's that, but it's basically your LLM can call a tool, so it can actually start doing things in the world So just imagine like with, you could actually say to your app, call me an Uber, or you can say to your app, I don't know, buy something for me, and your app can just do that because you have the thing implemented on your side or the side of the app. So I think there is a future for these things actually being useful. And that's pretty much it. Thank you.